Every autumn, a spectacular transformation happens across vast wetlands in North America. The fields turn red, not from leaves, but from cranberries. Millions of tons of these small, tart berries are harvested, processed, and turned into everything from juice to sauces and snacks. But how are cranberries grown, harvested, and processed at such an enormous scale? Let's go inside the incredible world of cranberry farming. Cranberries aren't your typical fruit crop. They don't grow on trees or tall bushes. Instead, they thrive in special low-lying wetlands known as cranberry bogs. These bogs are often built on top of natural marshes and require acidic peat soil, a reliable water supply, and a cold climate. That's why most commercial cranberries are grown in just 5 U.S. states: Wisconsin, Massachusetts, New Jersey, Oregon, and Washington, as well as in parts of Canada. Cranberry plants are hardy vines that can live for decades. In fact, some vines still in production today are over 100 years old. The farming season begins in spring. Once the frost recedes, growers begin prepping the bogs. New vines are planted in rows. Irrigation systems are checked, and bees are brought in during June to pollinate the cranberry flowers. As summer progresses, the tiny berries develop from green to white and eventually ripen into their iconic deep red color by early fall. Cranberries can be harvested in 2 main ways: dry or wet. But over 90% of commercial cranberries are harvested using the wet method, especially those destined for juices, sauces, and dried snacks. Here's how it works.
And how can we take care of the land so the land is taking care of us?
When the berries are ripe, usually from mid-September to early November, the bog is flooded with up to 18 inches of water.
And responsible to the industry as a whole.
We believe firmly in science leading the way in making decisions on how to grow better.
Then a harvesting machine called a water reel or egg beater churns through the bog, gently agitating the vines. This loosens the berries, which have small air pockets inside and naturally float to the surface. In a matter of minutes, the bog turns into a sea of red. Crews use floating booms to corral the cranberries into tight bunches. Pumps or conveyors then lift the berries out of the water and onto trucks. Each flooded bog can yield tens of thousands of pounds in just a few hours. For cranberries sold fresh in stores, a more delicate method is used: dry harvesting. In this process, bogs remain dry and a mechanical picker brushes the vines, lifting ripe berries without damaging them. Workers then collect the berries using bins or belts. While it's more labor-intensive, dry harvested berries have a longer shelf life and better appearance, ideal for Thanksgiving displays and holiday baking. After harvesting, the cranberries are trucked to processing facilities. Here, the first step is cleaning. The berries are washed to remove debris, leaves, and bugs. Next, they're sorted by color, size, and firmness. A series of screens, air jets, and water channels separate the ripe, firm berries from the damaged or unripe ones. Some facilities use optical sorters, advanced machines that photograph each berry and eject defective ones using tiny bursts of air. Only the best cranberries move on to the next stage. Now the berries are ready to become a wide array of cranberry products. For juice, the berries are crushed into a pulp and heated. The liquid is then filtered, pasteurized, and either bottled directly or concentrated for shipping. To make dried cranberries, the berries are sliced, sweetened, and dried using warm air tunnels. This process can take several hours and results in the chewy texture many people love in salads and trail mix. Cranberry sauce follows a different route. The whole berries are cooked with sugar and water until they burst. The result? A thick, tangy spread that's become a staple on holiday tables across North America. Meanwhile, cranberry powders, extracts, and capsules are manufactured for the growing health supplement market. thanks to the berry's rich antioxidant content. Once processed, the final cranberry products are carefully packaged. Juices go into PET bottles, cartons, or large commercial containers. Dried cranberries are vacuum sealed in plastic pouches or bulk bags. Cranberry sauce is canned or jarred. Each package is labeled with lot numbers, expiration dates, and quality control stamps before being boxed and palletized for distribution. These products are then shipped across the country and exported worldwide to grocery stores, bakeries, food manufacturers, and restaurant chains. From field to finished product, the journey takes just days, but the planning spans an entire year. Cranberry farming is deeply intertwined with the environment, and sustainability is central to modern practices. Growers use precision water management to minimize usage and prevent runoff. Floodwaters used during harvest are recycled across bogs. Integrated pest management techniques reduce the need for chemical pesticides. Native grasses are planted along the edges of bogs to prevent erosion and support pollinators. Some farms even use leftover berry pulp as compost, returning nutrients to the soil. And as consumer demand grows for traceable, eco-friendly products, many cranberry producers are investing in certifications and new technologies to reduce their footprint. Long before cranberries became a commercial crop, they played a vital role in Native American cultures. Tribes like the Wampanoag and Algonquin used cranberries for food, dye, and medicine. They even mixed cranberries with dried meat and fat to make pemmican, a high-energy survival food. Today, cranberries are a $1.5 billion industry in the US alone, with millions of barrels produced annually. But the tradition lives on. Families still gather to celebrate the harvest. Tours and festivals invite visitors to walk through flooded bogs, and Thanksgiving dinner just wouldn't be the same without a spoonful of cranberry sauce. From wild marshes to high-tech harvesters, from tart berries to sweet snacks, the journey of the cranberry is nothing short of remarkable. It's a story of science, nature, and history, blending tradition with innovation. So next time you sip cranberry juice or spread some sauce over your turkey, remember the incredible effort behind every berry. Cranberries, small in size, mighty in impact. If you enjoyed exploring the incredible world of cranberry farming with us, don't forget to subscribe to our channel for more behind-the-scenes documentaries just like this. We dive deep into how your favorite foods, products, and machines are made, from farm to factory and beyond. Hit the like button if you learned something new, and tap the bell so you never miss a story from the world of production. Thanks for watching, and we'll see you in the next one. Every year, millions of tons of sugar beets are harvested around the world. Humble root vegetables that transform into one of the most widely used ingredients on Earth, sugar. From the fertile fields of North America and Europe to high-tech factories running 24/7, sugar production from sugar beets is a marvel of agricultural science and industrial engineering. In this video, we'll take you behind the scenes of how sugar is made, from planting and harvesting sugar beets to extracting and refining the crystals inside, until it becomes the white granules we sprinkle into our tea or mix into desserts. Did you know that sugar is one of the world's oldest documented commodities? While the first indications of sugarcane's domestication were around 8000 BCE, extracting real sugar from beets is a more recent discovery. The modern sugar beet's roots are buried deep in history, politics, and geography. In 1747, 3 decades before the American colonies declared their independence, German chemist Andreas Marggraf discovered that sugar beet roots contain sucrose, the same sugar as that of sugar cane. Marggraf's apprentice, Franz Karl Achard, began selectively breeding sugar beets in 1784. In 1801, he opened the world's first sugar beet factory in what is now Poland. The sugar content of those first factory beets was 6% compared to modern beets, 15% to 20% sucrose. During the Napoleonic Wars 35 years later, the English blockade of continental Europe cut off cane sugar supplies from the West Indies. This prompted the development of beet sugar's commercial viability. By 1850, the sugar beet industry was well established in Europe. Sugar beets made their way to New England in 1836, but failed to take root. In the middle of the 19th century, an attempt was made to cultivate sugar beets in Utah, but that was not successful either. It wasn't until 1870 that the first successful sugar beet factory was built in the United States in Alvarado, California. It was then that the industry took off. By 1914, the United States rivaled Europe in sugar beet production. 3 years later, there were more than 90 sugar beet factories operating in 18 states. As of 2017, there were 20 operating sugar beet factories in 9 states, processing 35 million tons of sugar beets grown on more than 1 million acres. Today, sugar beets are grown in 52 countries. More than 4.5 million tons of sugar are produced each year in the U.S. from sugar beets, which represents more than 54% of domestic sugar production in the U.S. Sugar beets thrive in temperate climates with long daylight hours, such as the northern U.S., Canada, Germany, France, and Ukraine. Fields are plowed and leveled to ensure proper drainage, and GPS-guided tractors plant the seeds in precise rows, about an inch deep and several inches apart. As the beets grow, they begin to store sucrose in their fleshy roots. Within 90 to 120 days, the plant develops a leafy crown above ground, while the beet underground swells, eventually reaching the size of a football and weighing between 2 to 5 pounds. Farmers monitor the plants throughout the season using drone surveillance, soil sensors, and AI-driven irrigation systems. Weeds are controlled mechanically or chemically, and pests are managed using integrated pest control methods. As summer ends and autumn arrives, the beets are ready for harvest. At this point, each root can contain 15% to 20% sucrose by weight. Harvesting sugar beets is a delicate yet powerful process. Specialized beet harvesters move slowly across the fields, cutting off the leafy tops and lifting the beets out of the ground using rotating wheels and cleaning rollers. The beets are then transferred via conveyor belts into large trailers. Within hours of harvesting, they are transported, often in fleets of trucks, to nearby processing facilities, known as sugar beet factories or refineries. During peak harvest season, these factories operate around the clock. A single facility can receive up to 20,000 tons of beets per day. Upon arrival, the beets are weighed, sampled for sugar content, and stored in vast outdoor piles, known as beet clamps, that can stretch for hundreds of meters. These piles are ventilated to keep the beets cool and prevent spoilage. Before any sugar can be extracted, the beets must be thoroughly cleaned. The first stop inside the factory is the washing station, where beets are tumbled in large rotating drums filled with water to remove soil, rocks, and plant debris. Any foreign materials, such as stones or metal fragments, are separated out. Clean beets then move to the slicing machines, where they are cut into thin, French fry-like strips known as cassettes. This increases the surface area and allows for better extraction of sucrose. These cassettes are then sent into the extraction tower, a massive vertical chamber where hot water circulates countercurrent to the beet slices. Over about an hour, the hot water draws out the sucrose, producing a golden brown liquid known as raw juice. The leftover beet pulp, still rich in fiber, is pressed, dried, and pelletized to become animal feed, particularly for cattle and horses. Raw juice may contain around 12 to 14% sucrose, but it also includes impurities like organic acids, proteins, and minerals. To purify it, the juice undergoes carbonation and filtration. First, lime, calcium hydroxide, and carbon dioxide are added to the juice. The lime reacts with impurities and causes them to form solids, while the CO2 helps precipitate calcium carbonate, which traps unwanted compounds. The mixture is then filtered through massive rotating drum filters, removing the solids and leaving behind thin juice, a clearer, more purified solution. Next, the thin juice is concentrated using multi-stage evaporators, which boil off excess water under vacuum pressure. The result is thick juice, containing about 60 to 70% sugar. This syrup is then sent to vacuum pans, where it's boiled again under reduced pressure, causing sugar to crystallize out of the solution. Once the crystals form, the mixture, called massicute, is sent to centrifuges. These spinning machines separate the sugar crystals from the remaining molasses. The raw sugar is now white, but may still carry a slight yellow tint due to natural residues. Depending on the factory, it may undergo further refining, including charcoal or ion exchange filtration, to produce pure white sugar. Once separated, the sugar crystals are still moist and warm. They are conveyed into drying drums where warm air removes excess moisture. Then, the sugar is cooled on vibratory cooling belts to avoid clumping. At this stage, the sugar is graded by crystal size, fine, granulated, or coarse, and then directed to automated packaging lines. Some sugar is bagged in 1 kilograms or 5-pound retail packs. Others go into 25-gram sacks or bulk containers for industrial customers. Each package is labeled, sealed, and quality checked using laser sensors, metal detectors, and weight checks to ensure consistency and safety. The sugar beet industry is a model of zero-waste processing. Besides sugar, every part of the beet is used. The leafy tops are returned to the soil or composted. Beet pulp becomes livestock feed. The molasses is used for fermentation in ethanol production, yeast cultivation, or even as a feed additive. Waste lime is used as a soil amendment in agriculture. Factory water is recycled through advanced treatment systems. In many cases, sugar beet factories generate their own energy by burning biogas from beet residues. From a tiny seed to a gleaming spoonful of sugar, the journey of beet sugar is one of precision, science, and efficiency. What once grew quietly underground ends up on bakery shelves, coffee tables, and dinner plates around the world. Next time you sweeten your tea or bite into a cookie, remember, it might just come from a sugar beet harvested in a field thousands of miles away. Thanks for watching. If you enjoyed this behind-the-scenes journey, don't forget to like, subscribe, and stay tuned for more fascinating stories of how everyday things are made.